Okay, students, so the recording button is now on. Again, a very good morning to all of you. 5 Citrin. So far, we have 6 of you here. Good morning, Sun Xiang, Jun Wei, Sebastian, Wei Xiang, Xin Yin. All right. Okay, so anyone? Okay, then. Okay, so today, before we continue with the tutorial for 4.1, let us take a short look at what I have delivered yesterday in the classroom. Because since most of you are not in the class at that moment for attending the career fair at the whole. Okay, so this is the last learning standard in 4.1, learning standard 6, is to describe what are the factors affect the speed of rotation in an electric motor. Okay, students, so you know already that motor works based on uh, the electromagnetic, where the coil is placed in between a magnetic field and a force will be produced from there. So we can determine the direction by using Fleming's left-hand law. Okay, students. Can? Okay, thank you. Okay, students, so this is one example of activity conducted in the laboratory to study what are the factors affect the speed of rotation of an electric motor. So altogether, there are 4 factors. Okay, there are 4 factors. So this is the setup of the apparatus. As you can see, the power supply is connected to a direct current. The copper wire coil there is placed in between magnetic field. So we are using magnet as our permanent magnet there. Okay. Then if you read from the instruction or the procedure from number 1 to number 5, we adjust the voltage to 4 volt. Okay. And then we observe the speed and rotation of the motor. And then we repeat this experiment by increasing the voltage to 6 volt. So every time you increase the voltage, what happened to the current? Students, you learned from Ohm's law before in chapter 3. When the voltage is increases, so what happened to the current flow in the circuit? It is also increases. Okay, when voltage increases, yes, very good, Wasia. Current also increases. So you will see that what happened to the turning of the coil, become faster or become slower logically. When the current is higher, so it will rotate at the higher rate, it will rotate faster. Okay, and then we add more turns to the copper coil. Okay, turn on the power and observe the speed of the rotation again. Okay. Okay, then what can we gain from this activity? First, what is the relationship between current in the coil and the voltage supply, as I mentioned just now? How does the current and voltage relate, students? So how to write this? Current and voltage, what is their relationship? Anyone? Junwei, what do you say? Sebastian, Sunsian, directly, yes, directly proportional. It means that when the voltage increases, the current also increases. Very good. Okay, then describe the change in the speed of rotation of the motor. So this is what our manipulated variable. First, we increase the voltage. So when the voltage is increased to 2 to from 4 to 6, so what happened to the speed of rotation? You can see the speed of rotation should be increases. Okay. Then second, we maintain the voltage, mean we maintain the current in B, but we add more number of magnet. Okay, so when we add more number of magnet, it means that we increase the strength of the magnetic field. So what happened to the rotation? The speed of the rotation should be increases due to the stronger magnetic field. Okay, then the third, we maintain the voltage, we maintain the number of magnet, but we increase the number of turns of coil. Okay, so what will happen? Again, the rotation will be faster. Okay, it will speed at a higher rate. So from this, what are the factors affect the speed of rotation? So you can write the first one is due to the current in the coil, the magnitude of current in the coil. Second, the strength of the magnetic field. Okay, and third, the number of turns of coil. Okay. for this activity. Okay, then we can write all the four factors affect the speed of rotation. Again, the first one is the magnitude of current or size of current. So what happens when we increase the size of current, the speed of rotation also increases. Okay, second factor, the strength of the magnetic field. So when it is increasing, of course, the speed of rotation also increases. And the third factor, the number of turns of coil. So when we increase the number of turns, okay, the current will be greater, so the speed of rotation will be higher. And last but not least, by increasing the area of coil. Okay, students, when we increase the area of coil, what happened to the resistance of the coil? Student, we learned this in chapter 3 also. Increase the area of the coil mean we are using thicker coil. So what happened to the resistance? Resistance will be lower, right? Yes, very good. Lower resistance mean higher current along the coil, which mean higher current. So the speed of rotation will be higher. So all these four factors increase the force acting on the coil. So that's why they are rotating faster. The speed increases. So are you clear with this? Four factors affect speed of rotation of the motor, size of current, strength of magnetic field, number of turns, and then area of coil. Okay, so we go to the next part. Okay, this is the comparison between brushless and brush motor. Yang Mai kemarin ada di kelas, ada salin di papan putih. Okay, I give you the comparison between brushless and brush motor. Brush mean it has commutator and carbon brush. There you can see the commutator and the carbon brush. This one, it doesn't have. You can see is there is no carbon brush there. No carbon brush. Dia ada commutator saja. Okay, no carbon brush. So this is the structure. Okay, so what is the similarity between these two? First, both has magnet and coil. Okay, so this is the basic structure. Use magnetic force to produce rotation. Okay, so they are working based on the same working principle. Okay, then these are the differences. Okay, for brushless, the coil is stationary. The magnet is the one which rotates. Okay, the coil is remain stationary, but the magnet is rotating. For brush motor, the magnet, okay, is stationary, but the coil is the one that rotates. That is the first difference. Second, you can see there is no carbon brush there, so no friction, no contact between the brush and the motor. For this one, you can see the commutator is in contact with the brush, so it gives high friction when the motor works. Okay, so no sparking at the commutator since there is no contact. For this one, it will cause a spark. Okay, spark. Okay, ada percikan api. And then soft operational sound because there is no contact. So the motor is more silent. Dia lebih senyap. For this one, it is very noise. Sangat bising. Okay, louder operation noise due to the contact or the friction between the commutator and the carbon brush. So I hope you're clear with the similarities and differences between brushless and brush motor. But which one do you think is more expensive? Which one is cheaper, students? Which one do you think is more expensive, high cost? Definitely it will be the brushless. If you ask which one is better, you can see the brushless has an advantages. Yang ini lebih baik lah. Cuma dia lebih mahal, sensiang. Okay, brush cost high. No, the brushless is more high cost, sensiang. Okay, so you can check on the next part. Okay, this one. Brushless direct motor, this is the advantages. The first one, it produces no frictional force because there is no contact between the commutator and the brush since it don't have any brush at all. And it works with a very high efficiency because there is no friction produced, so it produces more percentage of energy. And then zero maintenance, very easy to maintain because since there is no contact, so it is also long lasting compared to a brush motor. But this is the advantages it has. It is quite expensive compared to a brush motor. Dia lebih mahal lah, high cost. Okay. Okay, students, so that's all with the brush and brushless motor. And this is the last part to build a simple direct current motor. So this will be your PBL project later after percubaan. For 5 citrin, I will give you one assignment on this. So you have to carry out, you have to do a project in building your own simple direct current motor, or we call it as a homopolar. By the students lah. Ini satu contoh di sekolah yang lain. Example of a simple direct current motor. But I don't want you to do this. I want you to work later with the homopolar. This one simple, very simple. Okay, design a simple and efficient homopolar motor. Okay, this is only the thing. Need a dry cell and then a circular magnet and then a wire. You can turn it to any shape. So when you place in between this battery and magnet, so you can see that the wire will be turned as shown in this short video. Okay. And CH rotating due to the magnetic effect, interaction between the magnetic effect from the battery and magnetic field from the circular magnet. So producing catapult field, producing a force acting on the wire, so it will cause a tuning effect. The coil will be rotate. Okay. Tapi after trial lah, sekarang you focus on your trial first. Okay, so this one. Now let us go to the exercises for this chapter. So far, do you have any question? What do you think about 4.1? Can you follow, students? 4.1. Jeb, good morning and welcome. Sun Xiang, yes, Jun Wei, Wei Xiang, Xin Yin. This chapter is actually not difficult to understand. Okay, nothing to calculate. Okay, for 4.1, only to apply a concept of Fleming left-hand rule. Okay, let us try on this objective question first, students. Question 1. Based on the diagram below, what is the direction of motion of the road when the switch is closed? Let us try on this question. Okay, you can put your answer in the in-call messages. This is our aluminium rod, the blue color, placed in between these two magnetic fields. South is on top, north is below, and you see the direction of the current flow. Okay, this is the terminal of the battery, so current flow in this direction. So can you tell me, along this aluminium rod, current flow out or current flow in? According to our diagram, Wei Xiang say B. Okay. So this is the direction. Is the aluminium rod move to A, move to C, move to B, or move to D? Okay, how to place your three fingers here? Fleming's left-hand rule. So this is the direct. If you draw, students, this is the direction of current from the positive terminal, then along the aluminium rod, and then it will go this way. Which means along this aluminium rod, it move outward. The current move out. So your middle finger point, okay, point out, pointing to you. It should pointing to you, to yourself. And then your index finger pointing where? Where is the south pole? Is upwards. So you twist your finger, index finger pointing south, pointing up. So you can see now your thumb pointing where? You punya thumb pergi mana? Pointing to B or pointing to D? Pointing where? Okay, so you can see it is pointing to D. So the answer is D. Very good, Jun Wei and Sun Xiang. Siapa jawab B tadi tu? Wei Xiang, tengok semula. Okay, so this one the current flow out. Okay, so middle finger pointing out, index finger pointing upward. So the force will be pointing to D. This is the direction of force. It moving to the left. Okay, question 2, very simple, students. Your middle finger represent what? X is your middle finger. It represent what? Is it the force? Is it the magnetic field or the current, students? Repeat what, Wei Xiang? Nanti sekejap cikgu repeat. Okay, B. Okay, remember this is F. Thumb representing force. Index finger representing magnetic field. Middle finger representing current. FBI. Okay, FBI. So the answer for number 2 is B, current. Repeat what? Which? Number 1. Wei Xiang. Okay, number 1, I erase back all the ink. Okay, first and foremost, you have to check, okay, the terminal of the power supply. So long leg ini positive terminal mean current flow in this direction. Okay, current flow in this direction. So across this, it flow out. It flows to the front, mean flows out. Okay, so your middle finger pointing out the current. Ini current, direction of current is out. Okay, and this one, the magnet, you see the south is on top. Okay, remember, this one for our index finger, it point from north to the south, always pointing to the south. Okay, so your index finger should pointing upward. So this is B. Okay, so current is like this. This is current, and then this is our B. So where is our force? Force is here, F, which is to D. So all these are 90 degree by using Fleming left hand. Did you get it now, Wei Xiang, number 1? So the answer is D. It moved to the left. Okay. Again, number 3, students. Find the correct direction of the force acting on the copper wire. Okay, so this is our copper wire we place in between these two bar magnet. This is the south pole on the left, north pole on the right. Okay, when the switch is turned on and it say that the current flow out of the paper. So now the current flow out. So this is the symbol, current flow out. Again, your middle finger pointing out, pointing to you. And then as your index finger are pointing to the south. So where will be the copper wire move to? Above or downward? For number 3. Above or downward? A or C? The answer is either 2 only, A or C. A or C. So for this one, the answer is yes, very good. It will move downward. Okay, for number 3, it will move downward. Did you get it all, students? Number 3, downward. Okay, so how to do this? Again, current pointing outwards. Okay, this is the current out. It say here flows out. So this is current. Okay, then this is our magnetic field. Okay, pointing to the left. Why pointing to the left? Because left is south. So the force pointing downwards. Okay, this is the force downward. Flow out of paper. See, flow out mean to the front. Flow out in this way. So this is your paper. It is your paper. So current flow in like this. Okay, into the paper, into the plane. Okay, kalau dia flow out mean out. Okay, so your middle finger should be pointing at you, point out, okay, out of the plane. All right. Okay, student, number 4. Okay, number 4 again, the direction. Okay, so here in all this question, we want to master you with your Fleming left hand rule. If you can understand Fleming left hand rule, all this question is actually very simple for you to determine the direction, either for the force, either for the current, or either for the magnetic field itself. Okay, we try number 4 now. Diagram shows a conductor wire placed in a magnetic field. So you can see this is our north pole on the left, south pole is on the right. Okay, this is the direction of current flow across the coil, student. So we have 4 directions, X, Y, W, and Z. So when the switch is on, so when you close this switch, which is on, the conductor will move where? Move to X, move to Y, move to W, or move to Z. Pergi mana? So how to place our finger here? Okay, now can you tell me current flow out or flow in here? Current flow out or flow in? The current flows to the front, right? Mean the current is flow out. Okay, it flows to the front from the positive terminal here. Okay, so it flows to the front. Mean it's flow out of the plane. Okay, so this is the current. And then this is our south. So if you place your finger, okay, so thumb pointing to the south, middle finger pointing outwards, so your thumb will be pointing upwards in the direction of X. Yes, very good. Siapa jawab X itu betul lah, X. Alright. Okay, that is number 4. Okay, did you get it all, students? Number 4. So the conductor will move to the direction of X, which is upwards. Okay, next student, number 5. Okay, try this. Again, we have a conductor placed inside the magnetic field. So now our north is on top, okay, the magnet, and south is below. And this red arrow shows the direction of current. So current flows in this direction across the conductor. So where will our conductor move? Move to X, Y, W, or Z. Okay, you place your finger first. So your index finger should be pointing downwards, pointing to the south. Okay, so index finger pointing to the south. Okay, this is south. Ini B. And this is the direction of current. Okay, so where? Where is the conductor move to? Move to where? Sebastian answer C. So it will move to Y, the direction of Y. Okay. Are you clear with number 5, student? Okay, so the direction is to Y. Or actually, there are two possibilities only, either to Y or either to Z. Dia takkan pergi X, takkan pergi Y. Okay, it either goes swing inwards or swing outwards. Outwards to Y, inwards to Z. Which one not clear, Junwei? Number 5. Is it? You are not clear with number 5, 4 and 5. Okay, we check for number 5 first. Okay, so first you have to check where is our magnet. Okay, north is on top, south is below, right? So you know your index finger should be pointing downwards. Okay, pointing downwards. Okay, you point your index finger downwards now. Okay, now where to point your middle finger? You just follow the direction of the arrow. Follow the direction of the arrow. So, where will be your thumb pointing? Thumb kamu pergi mana? Okay. Number 5. Is your thumb pointing to Y? So you have to twist. Okay. You place your index finger first on table, mean pointing to S. Okay. And then you twist your middle finger, follow the direction of the red arrow, showing the direction of current. Okay, so now you can see that your thumb will be pointing to Y. Dapat tak semua? Tan Zhen Su, good morning. Okay, did you get it down? Number 5, students pointing to Y. So kalau you lukis you punya jari, index finger pointing downwards, and then you punya middle finger pointing to this direction. Nanti you punya thumb pointing to Y. Ini thumb. This is index finger. This is middle finger. Okay, morning Zansu. Got it now, Junwei, for number 5? Okay. Okay, we check back tadi number 4. Number 4 ini pun sama. You tengok juga. Okay. The concept is just the same. We check, this is our terminal. Okay. So we understand this is the so the current flow to the front. Okay, the current flow to the front mean it flow out. And this is our magnetic field, south. So south is on the right, so our index finger should be pointing to the right and our middle finger pointing outwards. So you will see your thumb is now pointing upwards, pointing to X. You follow the direction only. Tengok dia punya arrow. Current place in this position. Where to place your finger? Finger kamu nak letak mana? You letak di sini on the wire. Okay, in this conductor. Not any place. Not at any other place. Letak di sini you punya finger. So, you place your finger there. Index finger pointing to S. So, middle finger pointing to the front. So, your thumb will be pointing upwards, the direction of X. Clear now? Number 4 and number 5? Okay, can you try number 6? Okay, number 6 ini, what do we call this? This is catapult field. Okay, catapult field is the interaction between magnetic field around the conductor and magnetic field from the permanent magnet. So when they are combined, they will produce a resultant field which is called as catapult field. Okay, so when you combine A and B, what will be the diagram of the catapult field or resultant magnetic field? Ini kita panggil catapult field. Okay, remember how to draw the catapult field? A you boleh tolak lah, ini salah. C pun salah, tak ada gambar macam ini. So the answer is either B or D. Okay, so if you look at this two diagram, what this X marks refers to? X marks ini maksud dia apa? Along the conductor, the wire is, the current is flow in. Okay, flow in. So the direction of the magnetic field is clockwise. Okay, so if you combine, okay, so for this permanent magnet, the direction of the magnetic field is from the north to the south. So at this side, which means the arrow is downward, right? Clockwise. On the left side, the arrow is upward on the conductor. Okay, so you can see this one, clockwise rotation, the magnetic field using right hand grip rule. Okay, so when we combine, okay, so if you look at the left side, okay, this is left. Left, magnetic field pointing downwards. But left for conductor pointing upwards, right? So they are opposite direction. So it means that the magnetic field at the left side is stronger or weaker, student? Opposite direction. Okay, when they combine, the magnetic field on the left, opposite direction, so they are weak. So on the left, they are weak. So you check, you compare between B and D. Where does it shows on the left it is weak? How to see? Less number of line. This one, correct. Okay, now checking on the right side. Okay, on the right side for the magnetic field, it is again downward. Okay, for the conductor, now it is also downward. So on the right side, the direction for the two magnetic field are the same. So when they are same, it means it produces stronger field at the right side. Okay, at the right side is stronger. So stronger means show by more number of line. Sini dia tunjuk more number of line. One line, two line, three lines. Ini show one line only. So the correct answer is B, which means finally the force will be acting to the left from the stronger magnetic field to the weaker magnetic field, which means the conductor will move to the left. Okay, so the answer for number 6 is B. Answer is B. Again, we call this as a catapult field. Okay, boleh faham nombor 6? You check only the direction, either they are opposite or same. Same direction produce stronger magnetic field, show by more number of line. Okay, opposite direction produce weaker magnetic field, show by least number of line. Okay, next. Question number 7. Okay, you are given two conductors, both connected to a 6 volt, and this is the direction of the dry cell, the terminal of the dry cell. Okay, so we check first on the left. Okay, the current flow in or flow out, student? Current flow in or flow out of the cardboard? This one on the left side. On the left side, flow in or flow out? Okay, where is the current flow? Current flow in this direction. Okay, when the switch is closed, current flow in this direction. So on top it flow out. Kita tengok yang atas. So here current flow out of the paper. Okay, flow out, Wei Xiang. Sun Xiang, flow out. This one on the left. On the right, how is the current flow? So this is the positive terminal. So current flow in this way. Okay. Then on top, it also flow out of the paper. Kalau nak tengok dia flow in or flow out, tengok yang bahagian atas, on top of the cardboard. Okay. So in both sides, current flow out of the paper. Yeah, upward. Okay. In mean downward. Okay. Yeah, upward mean out of the paper. Tengok dia keluar daripada kertas. Okay. Kalau dia move down, mean dia move into the paper. Masuk dalam kertas. Okay, so which magnetic field pattern form on the cardboard when both switches are closed? So what method we want to use here to determine the direction? what method is to use to determine the direction? So we are using right hand grip rule. Okay, so on left, you place your grip upright. Okay, upright because current, the thumb shows the direction of current when you are using right hand grip rule. So look at the focal finger. It curl clockwise or anti-clockwise when current flow out. Okay, your forefinger curl clockwise or anti-clockwise, students? On the left. On the left. Clockwise ke? Tengok betul-betul. See your grip. Okay, you grip a pen. Try to grip a pen, your thumb pointing upward. See your focal finger. It curl clockwise or anti-clockwise? It curl anti-clockwise. Okay, on the right is also the same. Okay, since the current flow out, okay, you try to grip your pen or anything you have there. Okay, so your thumb pointing upward. You see your forefinger curl to the direction of anti-clockwise. So which one is the answer? Both curl in anti-clockwise direction. A, B, C, or D? So you can see clearly the answer is B. Okay, answer is B. Okay, now try number 8. Okay, number 8, very simple. First and foremost, you must understand what is meant by this symbol, X mark. X mark show current move into the paper. Okay, move into the plane. Okay. Then north is on top, south is below. So where the conductor will move to? Move to A, move to B, move to C, move to D. Again, we apply Fleming left hand rule here. Okay, so place your finger there at the X mark. So it should point into the X mark, into. And then your index finger pointing to the south, which is downwards. So check, where is your thumb pointing at now? Sebastian say A, Sun Xiang say A. The rest of you, did you get number 8? Okay, put your fingers down at the X mark pointing in, and then your index finger pointing to the south. So you'll find out your thumb will be pointing to the direction of A. Very good. Okay, senang kan? Sekarang boleh faham ke? Fleming left hand rule senang saja. Kalau tak boleh pusing, jangan pergi tukar tangan kanan salah nanti. You dapat jawapan yang salah. Try to twist it as much as possible. Okay, kalau you turn to right hand, nanti dia sudah salah konsep because this one we only use in 4.2 magnetic induction. Alright, okay, check number 9, student, the last 2 questions for the objective. Okay, now we have a coil. A coil. This is a coil placed in between a magnetic field. North on the left, south is on the right, and this is the terminal of the battery. So from the terminal, you understand current flow in this direction. Okay, so current flow in this direction mean on the left side of the coil, the current flow in or flow out here. Flow in or flow out on the left. See my drawing. Flow in or flow out on the left side, the current. Flow in, Sun Xiang, flow in. Into, dia masuk dalam. Okay, flow in. And then it move in this direction. Now on the right side, the current flow out. Dia keluar, flow out. Okay, so this one current flow in on the left side. On the right side, the current flow out of the coil. Okay, so which one show the correct magnetic field pattern when the plane of the coil is horizontal? Okay, in this position now. Okay, which one is a correct magnetic field? A, B, C, or D? So what happened to the left side of the coil, student? Okay, can you place your Fleming left hand rule here? Fleming left hand rule. Place your finger on the left side of this coil. Where will the coil turn? Turn up or turn down on the left side? So your middle finger pointing in because the current on the left is inwards. Okay. And your index finger pointing to the south. So where is your thumb pointing at now for the left side? Pointing down. Okay. Here you will find F is acting downward. Okay. Now bring your finger to the right side. Okay. Bring your finger to the right side. Current now flow out. Okay. So your middle finger flow out. And then your index finger pointing to the south. So you'll see that now your thumb pointing upward. Okay, which means this coil will rotate in this direction. Okay, it will rotate in anti-clockwise direction. So this one turn down. On the right side, turn up. Okay, so which one is the correct diagram? So first tadi you tengok cikgu sudah lukis ini kan X mark. So this one on the left should be X. So all diagram X mark on the left, dot mark on the right. Okay, itu semua tak ada masalah. Semua sama. Okay, then you have to check for the force. It moved downward on the left. It means that which magnetic field is stronger, on top or below, students? On the left side. Since it is moved downward, it means it has a stronger magnetic field upwards. So ini betul. Okay, this one also correct. These two are wrong. Because if they show this drawing, mean this conductor will move upward. So C and D is wrong. Okay, and now you check on the right side. Okay, on the right side, the coil turn upward. It means that it has stronger magnetic field downwards, so pushing the coil upwards. So which one shows stronger magnetic field? Okay, this one stronger, correct. This one wrong. Ini tadi sudah salah kan? So the answer is A. Which one is the correct drawing? Correct drawing is A. Okay. So this one sama juga, we apply FBI. So you check on which side moving down. The other side must be moving in the opposite direction. So it will turn either in clockwise or anti-clockwise, depend on the flow of current, depend on the position of the permanent magnet. Okay, that goes for number 9. Okay, number 10, students. Again, we have a coil, electric motor. So remember, an electric motor is a device consists of a coil placed in between magnetic field. Okay, so it will cause a tuning effect on the coil. So that's how the motor works. Okay, this question is on the factor effect. Okay, the rotation of a coil in a motor. So which magnitude of force? Magnitude of force F increases when? Is A correct? Number of turns of the coil wire decreases, correct or not? This one is wrong because decreases. It should be increases. Magnitude of the electric current decreases. It should be increases. So this one wrong. Magnitude of the magnetic field decreases. This one also wrong. Should be increases. So the resistance of the coil decreases. Yes, resistance decreases means current increases. So when current increases, speed of rotation is higher, as we discussed earlier in the previous slide. So answer for this one is D. Okay, so you have to remember the 4 factors affect rotation. The first one, magnitude of current. Higher current, higher rotation, higher speed. Second, what is the second factor? Strength of magnetic field. Stronger magnet, higher force, so higher rotation, higher speed. Third factor, number of turn of coil. More number of turn of coil, so the greater the force, the higher the rotation. And last but not least, the area of wire. The bigger the area is, the lower the resistance, mean the higher the current flow. So higher the force, higher the speed of rotation. Okay. Okay, that I ada satu lagi nombor 11. I think this is the last question on objective. Okay, we try, student. Diagram 26. We have wire QR. Can you see QR there? Wire QR initially in this position, placed in between 2 strong magnets. So this is our magnet. South pole on top, North pole below. And this is the direction of current. My diagram is quite blur. You tengok you punya kita. So on top ini is the positive terminal. Below is negative terminal. So we check first the direction of current flow across this conductor. Current flow from R to Q or from Q to R? Okay, can you tell me current flow from R to Q or from Q to R? You just follow the path. So current move from positive terminal, so enter. So current move from R to Q, right? Current move from R to Q mean it move out. Current move out. R to Q. Kita punya conductor QR. So this end is R, the other end is Q. So current move out from R to Q. So you place your middle finger outward direction. And then your index finger pointing where? Your index finger pointing where? Pointing upward, pointing to the south. Okay, the angle of deflection increased by student. Okay, this one another factor. Okay, another factor to determine the angle of deflection. So how to increase the angle of deflection, student? Is it by increasing the current, changing the polarity, increasing the resistance, increasing the distance? Changing the polarity, not increase, only change the direction. Increasing the resistance will lower the angle. Increasing the distance will make the magnetic field become weaker. So the answer is yes, A, increasing the current. Okay, very good. Okay, so that's all with the objective question. Okay, now we check a few question on paper 2. Ken, ini soalan ni tak banyak kan? Sikit saja. Okay, again, you are given this diagram to show to study effect of force on a current carrying conductor. So this is our terminal of the power supply. We have copper wire XY there. Okay, and this is our magnet. South is on top, north is below. Okay, what is the direction of current in the wire, student, when the switch is on? Okay, the direction of current, X to Y or Y to X? X to Y or Y to X? Baca soalan betul-betul, kita punya conductor XY. Tak ada N lah, silap. Okay, so the answer is X to Y. Very good. From the positive to negative, so from X to Y. Yes. Okay, then explain the motion, student. Macam mana nak explain the motion? So you can explain due to catapult field. See wrong. Okay, no problem. So this is the way we explain. Slide ini cikgu sudah share ya dalam you punya Telegram group. Later you can check from that. So cikgu pergi cepat sedikit lah untuk ini. So the motion produced due to the interaction between two magnetic field. The first one is around the current carrying conductor, mean around the copper wire. Another one is magnetic field from the permanent magnet. So when they are combined, they will produce resultant magnetic field, which we call as a catapult field. And as a result, a force will be produced acting on copper wire XY. Okay, and the direction can be determined due to Fleming's left hand. Okay, next question 7 is stated here. So again, this is the diagram you are given. We have two permanent magnet. We place a conductor in between the permanent magnet, and this is the direction of current flow. Okay, so along the conductor, you can see the current here is flow in or flow out according to them. Current flow in or flow out? Or flow out. You see, it flow out, keluar, okay, it flow out. So, what's the question? First, name the rule determine the direction of force. So, what means and rule? Okay, Fleming's left hand rule. Okay, in diagram 7.2, draw the resultant magnetic field produced. Okay, so this one you have to draw the catapult field. Okay, you can try to draw the catapult field. Okay, so this is the key given current out of the paper. This one shows current out of the paper pointing to the south. So when you draw the catapult field, you will find out, okay, stronger magnetic field on the right side, weaker magnetic field on the left side. So finally, the conductor will be pushed to the direction of F, pushed to the right. So this is the final position of the conductor after a force acting on it due to the interaction of these two magnetic field. Okay, so you can draw your catapult field. Okay, so this is our conductor, dot mark. if you draw the magnetic field here, so dia punya magnetic field for out is anti-clockwise, right? So this on the right is downward, on the left is upward. So on the right is the same, this one pointing downward, magnetic field, and this one pointing down. That's why it is stronger on the right side and weaker on the left side because the direction of the arrow is opposite. Okay, so a force will be produced acting to the left, pushing from a stronger magnetic field to the weaker magnetic field. Okay. Okay, then next student for question B. Okay, question B, this is a moving coil emitter. Okay, moving coil emitter. Emitter is used to measure what? Students, 5C3. We use emitter to measure current. Okay, yes, to measure current. Okay, you can see all the structure there. The question is the scale of the emitters in 7.2 is not uniform due to the incorrect shape of the magnet used. Okay, you can see what is the shape of the magnet used now. What shape is this? What do we call this shape? This is rectangular, right? Rectangular shape. When you are using this rectangular shape, what do you think will happen to the rotation of the coil? Okay, the rotation will be uniform. Okay, the rotation will be uniform because for rectangle shape, it will produce non-uniform force. Dia punya force tak constant. Okay, in some position the force is stronger, in some other position the force is weaker. So that's why this called rotate uniformly. So you dapat uniform, okay, ununiform reading. Alright, tengok dia punya scale tak sama. So in this shape below, draw the correct shape of the magnetic field. So normally in a motor or in any devices using this application, what kind of shape we are using? Normally we are using radial shape magnetic field. Kita pakai, or you can say curve shape. You can see. Kita pakai curve or concave shape. You can also call concave shape magnet, okay, or a curve magnet or a radial magnet. Okay, that's it. This is the shape. So by this, you will see this is the field produced. It is concentrated at the center, which means it will make sure the coil rotate uniformly at a constant speed all the time. Okay, so this is the reason. Produce radial magnetic field, or produce stronger magnetic field, or produce uniform force on the coil so it will rotate steadily at a constant speed. Okay. Soalan ni pun biasa keluar dalam SPM, apa shape yang sesuai. So kalau dia tunjuk gambar macam ni, you select this one, curve shape, radial shape, concave shape of magnet. Okay, and then next, okay, we check. Okay, this is example of essay question. Okay, a few example of essay. Show 3 electric motor, design X, Y, and Z. So they give you 3 choices. You are about to buy a motor. You are going to use that in a small portable fan. Okay, you want to build your small portable fan, for example. So which motor is best for you to buy? Is it X, is it Y, or Z? So there are a few characteristics you can see there. The first one, you can check on the fan blade. Okay, tengok fan blade, apa beza fan blade dia, sama ke? Fan blade. Okay, then what else? The number of turn of coil. This one use 50 turns. This one use 10 turns. This one use 50 turns. Okay, then what else you can see there? Number of battery. This one use 3 battery. Y is, okay. Z also use 3 batteries. Okay, any other difference? Ada lagi tak bezanya? Okay, look at the shape. The shape of the magnet used. This one use semicircular shape magnet, radial shape. This one use rectangular shape magnet. Z also use rectangular shape magnet. So which motor do you think is the most preferable one? The first one, check on the number of turn of coil. Should be more or should be less, students? Number of turn of coil. Can I write 50 turns? Boleh tak cikgu tulis nombor di sana 50? Jangan tulis nombor ya, you write like less or more. Remember, you write more or less. More. Okay, greater, more. Why? So increase the force, increase the strength of the magnetic field. That is the reason. Okay. Then second factor, number of battery use. Okay, want to use 3 or 1? Boleh tak cikgu tulis 3? 3 batteries. Cannot. Again, you can use greater or more. More batteries, greater number, more number of batteries. Why? What is the advantages of using more batteries instead of using single battery only? So supply greater current. Okay, supply greater current. Increase the current. Current higher. Current bigger. Current greater. Okay, then shape of the permanent magnet. So which one? Semicircular or rectangular? I mentioned just now, we choose the semicircular. Semicircular. Why? Same reason as before. So it produce uniform force on the coil or the radial magnetic field, produce radial magnetic field, or you can say increase the strength of the magnetic field. Okay. So which of the most suitable design? So we choose motor X. Okay, we choose tulis X pun no problem. We choose X. Motor X is the best choices. Alright, according to all the characteristic listed before. So this kind of question will be on in your structure question in section A. It will be on number 7 or number 8. And then we have one more in essay question in section B. Okay, students. So I guess that's all with the exercises. Okay, so we've done with 4.1, tutorial 4.1. Any other question you would like to ask? Any question you are not very clear with? So you can ask now. Since we have finished with our discussion. Okay, anything you want to ask? Anyone who's still here? Any question you are not very clear with? Okay, you can ask now. Okay, before that, I end this recording first. So later, who cannot join this lesson, you can watch back the recording session. All right. Okay.